Hello everyone, I am Sukirti. I am an educator guiding, helping and motivating students from last so many years. Welcome to my channel Learn, Practice, Achieve. Today we will discuss real numbers exercise 1.2. But before going to the exercise, let us first make it clear what are the concepts included in this exercise. So first discuss those concepts, then we will start exercise 1.2. Okay, so first we will discuss about the fundamental theorem of arithmetic. So what it is, fundamental theorem of arithmetic? Every composite number can be factorized as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. It means whenever we will take any composite number, that composite number can be represented in the form of the product of prime numbers, and that prime numbers are unique. Unique means for any composite number the same prime number will come if we will do it in any way. Okay, and also apart from the order in which the prime factor occurs. But whenever we are finding out the prime factors, generally we write the prime factors in the form of ascending order. But here in fundamental theorem of arithmetic, we can represent that prime factors in any way, means the sequence you can change. Okay, so let us take one or two example to find out how these arrangements are there and how these composite numbers can be factorized as the product of prime numbers. Suppose one number we will take 60. So first find out the prime factorization of 60. So when you will find out the prime factorization, we will divide it by 2. So you will get 40, then 2, then 15, then 3, 5, and then 5. It is 1. So when we will represent this prime factorization of 60, we can write it as 60 is equal to 2 into 2 into 3 into 5. So here we have written it in the form of ascending order. First we have taken 2, the smallest number, then 3, then 5. This number can also be written in the form of, suppose 3 into 5 into 2 into 2. It means we can change its order, or it can be written as 5 into 3 into 2 into 2, or in any other way. Suppose we will take some other example. Let the example is 850. Okay. Again, large number is 0, so it will go by 2. So 2 4s are, then 2 2s are, then 2 5s are. Then we can take 5, 5 8s are, and 5 5s are. Again by 5, so it is 17. Then by 17 you will get 1. So prime factorization of this number 850 can be written in the form of 2 multiply 5 multiply 5 multiply 17, and this can also be written as 5 into 2 into 17 into 5, or it can be written as 17 into 2 into 5 into 5. So there is no fixed way to write down this prime factorization. You can write it in any way. Now we will discuss how to find out SCF and LCM of two given numbers. If two numbers are given, composite numbers are given, how to find out the SCF and LCM of those numbers, or if the prime numbers are given, then also how to find out. So how to find out the SCF of any given number? Product of the smallest power of each common prime factor in the number. So to find out the SCF, when we will make the prime factorization of any given number, from those numbers we have to take the smallest power of each common factors. So when we are finding out SCF, either we are taking two numbers or three numbers. So the common factors which are there in those numbers, we will take the smallest power of each common factors. Okay. In the same way, when we will find out the product of the, when we will find out the LCM, it is the product of the greatest power of the each prime factor involved in the number. So when we are finding out the LCM of two given number, at that time also we will prime factorize the number. After the prime factorization, we will take the highest power of the common factors. So first of all, we will discuss what are those numbers. If we will take any number, how to find out the SCF and LCM of those given numbers. Okay, so let the number be, one is 12 and other one is 16 suppose. So find out the prime factorization of 12, that is 2 into 2 into 3, and prime factorization of 16, that is equal to 2 into 2 into 2 into 2. So when you will write this number in exponential form, this is equal to 2 to the power 2 multiply 3, and here when you will write it in exponential form, this is 2 to the power 4. Now come to this SCF part. So when we are finding out the SCF, so according to the definition of SCF, what it is written? Product of the smallest power of each common prime factor. So first of all, find out the common factors. Common prime factors here are 2 and 2. So here the power of 2 is 2, here the power of 2 is 4. So we have to take the smallest power of the number. So here we will take the smallest power of these two numbers, that is equal to 2 to the power 2. So here SCF is equal to 4. Okay. In the same way, product of the greatest power of each prime factor involved in the number. Again, they are the numbers, first of all, which are common. We will take that one. Okay. So when we are finding out the LCM of the given number, LCM is equal to product of the greatest power of each prime factor. Product of the greatest power means here it is 2 to the power 4, and the other prime factors between these two which is left is equal to 3. So 2 to the power 4 is equal to 16 into 3. So the LCM is equal to 48. Clear? Now we will discuss what is the relationship between two numbers, their SCF and LCM. Okay. So LCM of, suppose any two given number is A and B. So LCM of A and B, when we multiply with SCF of A and B, we will get the product of A and B. So from this formula, we can derive these four formulas. How? From this, suppose we have to find out LCM of A and B. So LCM of A and B is equal to product of the number divided by SCF of the number. Okay. In the same way, SCF of A and B is equal to product of the number divided by LCM of the number. Suppose we have to find out any one number. So that number is equal to LCM of the given number into SCF of the given number divided by the other number. In the same way, if the other number you have to find out, LCM of the given number multiply SCF of the given number divided by the number given. Okay. So in this way, from one formula, we can derive four different formulas to solve the problems. Okay. So to solve this one or to prove this one, let us take two numbers, that is suppose 24 and 36. Okay. Let us find out the prime factorization of these two numbers. So 2, 12, then 2, 6, then 2, 3, then 2, 1. So the prime factorization of 24 is equal to 2 into 2 into 2 into 3, that is equal to 2 to the power 3 into 3 to the power 1. In the same way, when we will find out 36, then again it will go by 2. So 2 8 is 16, then 2, 9, then 3, 3, and 3, 1. So when we will write 36, that is equal to 2 into 2 into 3 into 3, that is equal to 2 to the power 2 into 3 to the power 2. Okay. Now we have to find out SCF and LCM. So SCF of these two given number, SCF is equal to the common factor which has the highest power. So here the common factor which has the highest power is equal to 2 to the power 3, and here 2 to the power 2. So when we will take the highest common factor with the lowest power, so that is 2 to the power 2. Okay. So this is equal to, and here it is 3 to the power 1. So 4 into 3, that is equal to 12. And in the same way, when we will find out LCM of this given number, then we will take the highest power of the prime factors. Okay, and the factors or the numbers which are left. So all the numbers we will take with the highest power. So here we will take 2 to the power 3 into 3 to the power 2. So here it is 8 into 9, that is equal to 72. So 12 is your SCF and 72 is your LCM. Now according to the formula given, LCM of A and B is equal to SCF of A and B. Now LCM and SCF when we will multiply, it means 72 multiply by 12. So here 72 is LCM and 12 is HCF. So when you will multiply these two, you will get 864. Now that is equal to A into B. So the number A and B here are 24 and 36. So the numbers 24 into 36, where 24 is A and 36 is B, and when you multiply these two, again you will get 864. So according to this rule, LCM of A and B into SCF of A and B is equal to the product of A and B. So here LCM, the product when you will take LCM and SCF, and the number when you will take and find out this product, then you will find that 864 is equal to 864. So we can say that this rule is proved. Now we will start exercise 1.2, question number 1. In question number 1, it is given that express each number as a product of its prime factor. Now we have already discussed what are prime factors. So here in question number 1, 5 parts are given, but we will solve only 2 parts. One from 3 digit and one from 4 digit. Okay. So when we will find out the prime factor of this number, we will express it in the form of its product and show the result. Okay. Rest of the question you will practice so that you will learn how to do it and you will achieve your target. So we will start with question number 1, second part, that is 156. So first find out the prime factorization of 156. Last number is 6. So it will easily go with 2. 2 7 ja, 2 8 ja, then 2, 2 3 ja, 2 9 ja, then 3 14, then 13 1. So 156 can be written 2 into 2 into 3 into 13, and because 2 is repeating here, so we can write 2 to the power 2 into 3 into 13. Okay. In the same way, when we will find out the prime factorization of 5005, then because the last number is 5, we can take with 51001. Then it will go by 7, 7 1 ja, 7 4 ja, then 7 3 ja. After this it will go by 11, 11 1 ja, 11 3 ja, then by 13, then 1 ja. So this can be written as 5005 is equal to 5 into 7 into 11 into 13. Okay, and this prime factorization you can write this number in any order. Okay, so not only in ascending order, you can change the order of these numbers and you can write the answer. अगर आपको मेरा आज का वीडियो अच्छा लगा तो सब्सक्राइब करना बिल्कुल भी नहीं भूलना, और आगे जो हम एक्सरसाइज डिस्कस करेंगे, एक्सरसाइज में मैं सब्जेक्टिव क्वेश्चन कराते कराते उसके बीच में मैं आपको डिफरेंट टिप्स और ट्रिक्स बताऊंगी जो कि आपके एमसीक्यू को भी सॉल्व करने में इजी होगा। फिर भी अभी तक हमने जो भी डिस्कस करा है उसमें अगर कुछ आपको डाउट है, कोई प्रॉब्लम है, तो आप ईमेल के थ्रू मुझे कांटेक्ट कर सकते हैं या कमेंट बॉक्स में आप लिख सकते हैं। सो प्लीज like, share and subscribe my channel, and don't forget to hit the bell icon to get my new upcoming videos. Thank you for watching.